So here we are, question 5, paper 2. A trigonometry question. It starts off, well, okay, here's an abstract trigonometry question, moves into a more practical trigonometry question, which involves a bit of area and volume as well. So it says the following, which I imagine people wouldn't love the look of. A lot of people wouldn't. Given that the tan of 45 degrees minus A is equal to 1 minus tan A all over 1 plus tan A, show that tan of 45 minus A is equal to cos 2A, all over 1 plus sine 2A. So, I know myself, a lot of students just aren't that familiar with this type of question anymore. 10 years ago, very common type of question. We would have practiced a lot of them, but it's just not so common now. People won't necessarily see straight away that really what you're trying to show is that 1 minus tan A over 1 plus tan A is equal to cos 2A over 1 plus sine 2A, because they're both equal to the part that's still highlighted in yellow, tan 45 minus A. So what are we going to do? Well, we're told this. We're told that tan 45 minus A is equal to 1 minus tan A over 1 plus tan A. So as I always say, if you don't know what to do, do what you know. Do something. See what happens. So, well, we know that tan A is equal to sine A over cos A. I'm hoping we know that, right? So sometimes it's a matter of just trying that. And then you might say to yourself, okay, when I look at my answer here, what I'm looking to get, particularly the numerator, there's no separate term over here. So we say, let's try this. Let's try and get a common denominator here. So if we just work out the part on the top first and look at this, we say we have a common denominator of cos A, because we'll call this 1 over 1. And similarly, we'll do the same in a moment down here. We'll call that 1 over 1. And so our common denominator is going to be cos A. So for this part in orange, we go back to this. So I'm going to say, okay, cos A is going to be my common denominator. What did I do to 1? What did I have to do to this 1 down here to get the common denominator? I had to multiply by cos A. So I'm going to have to do the same to the 1 on top. On the right-hand side, I didn't really have to do anything. So I'll still have my minus sine of A. Underneath the line then, again, a common denominator of cos A. So what did I have to do to the 1 over here to get the common denominator? I had to multiply by cos A, so I'm going to have to do the same to the top. And I didn't have to do anything to the part on the right. So now I look at this and I have a compound fraction. So it's like saying if you had 3 over 2 over 5 over 2, well, you can invert the denominator and multiply. So you'd have 3 over 2 multiplied by 2 over 5. The 2's will cancel and you're left with 3 over 5. So in the same way here, just looking at this fraction here, I have cos A minus sine A over cos A plus sine A over cos A. So I can just cancel those two. They're going to divide into each other if you invert the denominator and multiply. So you're left with cos A minus sine A all over cos A plus sine A. So a lot of people now at this stage, even if you've done that, you say, God, I'm no closer to getting to my answer up here, but you actually are. Now, the next part, like, how do you know to do the next part? Well, it's kind of half art, half science. It's through the practicing these questions, you see the likely strategies that are to work. So we can see we're not where we need to be. So in this case, what I'm going to do is I'm going to multiply above and below by cos A plus sine A all over cos A plus sine A. Now, it's okay to do that because if I multiply anything, like if I multiply the top and the bottom by 5 over 5, well, 5 over 5 is equal to 1. So, you're not doing any harm doing that, okay? So I can do that. Now, why do I do it? As I said, it's sometimes, with enough practice, you kind of get the instincts of the only things you can try that might work. You could try multiplying by cos A minus sine A as well. And in a long-winded process, you can still get to the answer. So when we multiply this through, we end up with a kind of difference of 2 squares above the line. So you have cos A times cos A gives you cos squared A, minus sine A plus sine A gives you minus sine squared A, and you'd end up with a plus cos A sine A and a minus sine A cos A, and they cancel out. So underneath the line, then you end up with, because there's no minus sign, you end up with cos A times cos A is cos squared A. sine A times sine A is sine squared A. Sine squared A. And then the difference between this part and the top part is you end up with a 2 sine A cos A underneath the line. Okay? Because when you multiply cos A times sine A, you get cos A sine A. And when you multiply by sine A by cos A, you get cos A sine A. So you have two of the same thing. So you got two lots of sine A cos A. Now, and I'm saying, when I say sine A cos A or cos A sine A, it is the same thing, obviously. No. So in this moment, again, you're kind of looking back up and you're saying, well, am I close to my answer? It turns out you're very close. You're very close. So what we could do here is, this is, something that some of you may have done at the very start, and you could work the other way around as well. You could start here and work your way back to there, and that also works. So in this case, what we're looking for is something that looks like cos of 2a, and there it is. Look at that. Cos of 2a is cos squared a minus sine squared a. We also can see that 2 sine a cos a is equal to sine of 2a. So on page 14, we have a lot of clues for how to get to the answer. And we're going to use those clues, and we're very, very close. We're almost there. We're one line away, and we're going to use what we have here to get there. And so our final step is we remember that, as we said, cos squared a minus sine squared a is the cos of 2a, just as we wanted. We remember that sine of 2a is 2 sine a cos a. And then we're just left with these two little parts here, cos squared a and sine squared a. But we remember as well that cos squared a plus sine squared a is equal to 1. So we've come across that a few times. And because of that, we end up with the answer that we want. In this case, it's only 5 marks. We've seen that in the Leaving Cert many times in the last few years, that the abstract, more difficult part can be worth the least marks. And so in this case, we've done that here as well. So well done to anyone who got there. Remember, you can start off with your answer as well and go from there and try and work your way back to your starting point. And that is also totally valid. And can be a good way to do it if you're stuck. Part B is completely separate from part A. The diagram shows the square ABCD of side 8 centimeters. On the side, DC is an arc of the circle whose center is O. So here's our arc, DC. The midpoint of AB is that point O. Show that DO is 4 root 5. So after the last part A, you might be thinking this would be very hard. But in reality, it's just Pythagoras' theorem. We have all the information we need here because O is splitting AB, which is 8, in half. So using Pythagoras' theorem, we're going to get DO squared is equal to 80. DO is equal to root 80. It's 4 root 5. And it's a nice handy 5 marks for that. So we have that in the bag. Okay, now we must calculate this angle here. And this is something I'd always say. If we didn't have part A, which was the difficult trig bit, if that wasn't there, I bet you everyone would do absolutely fine in part B. But sometimes people struggle in part B because they're kind of thrown by part A. So that's something we just have to get used to. We know this is 4 root 5, so therefore we know that's 4 root 5. And you could say, are we certain? Well, of course, the lengths are the same, so it must be. So now we can use the cosine rule to find the angle here at O. So that's the angle we're looking for. So of course, the side 8 is across from that in the triangle. So like in the case of our diagram here, the 8 would be the A, and the angle A is what we're looking for. So angle DOC. So we simplify this down, right? You got to be a bit careful here, right? That's going to be 80 and that's going to be 80. You got to remember this is the coefficient on the trigonometric part. So I think that's going to be minus 160 cos the angle DOC, right? So sometimes, because this will be 80 and this will be 80, sometimes people will say, okay, that's 160, and they'll subtract this other part. Did that happen to you? I bet you it did happen to some of you guys. So you got to be careful with that. So instead, we're going to have, when we isolate the cos of the angle, we're going to have 80 plus 80 minus 64 over 160. So we're going to have 3 over 5. We're going to get the inverse cos of 3 over 5. We were in radians earlier, we're back in degrees now, and it says corrected 2 decimal places. So you want to get that right for 10 marks. And in reality, a pretty easy 15 marks there, for the part B, 1 and 2. And our last part then is to calculate the area of the shaded region. And again, not too bad. As I mentioned at the start, there's a bit of area and volume in this question. We're finding the area of the sector, and it's the sector of a circle. Okay, we could extend that round. Not the best looking circle in the world, but you get the meaning. And because we know this angle here is 53.13, we can calculate the ratio of the circle that is there. It's like a ratio of the circle. It's like, the proportion of the circle. It's 53.13 over the total rotation, which would be 360 in a circle. And then we're multiplying that by pi r squared. So if we're getting the area of the full circle, it'd be 80 pi. But in our case, it's 80 pi multiplied by 53.13 over 360. I'm looking at my question. I want to correct to 1 decimal place. So it's going to be 37. Oh yeah, but I'm going to hold on now because I'm going to get my final answer. It's my final answer. And as a general rule, we like not to round until the very end. So then we're going to get the area of this triangle, DOC, and that is a half AB sine C. So a half AB sine C, so a half one side times another side times the sine of the included angle. And in that case, we're going to get 31.999. We're going to subtract the 2 from each other. And I've simplified it down here a little bit, but you'd be as well just to keep it like those two. Do your subtraction and make sure you're getting it correct to the 1 decimal place. And because it is an area we're looking for, it is 5.1 centimeters squared. And so that was another 10 marks. So again, predicting this, I'd imagine a number of people looked at this and said, oh my God, that first part looks horrible. I'm going to keep moving. And even the diagram yourself, itself, you might have thought was a bit tricky looking, but in reality, there was 25 pretty easy marks there to be gained. And of course, you could get mid-partial credit pretty easy from the part A as well. So that's one of the lessons to learn doing these ones. Sometimes the part A might be the trickiest part, not the rest of it. Okay, let's go on to question 6.